um, so yeah, you need quite a bit. You have quite a bit of overhead to actually maintain these systems. But yeah, the promise of the cloud is that you just you click the right mouse button 20 times, and then you have your Hadoop cluster there, without the need for any engineer. So currently the big three. So let's say Amazon, Azure, and Google. They have their own flavor of Hadoop distribution. So Amazon has this thing called EMR. I think it's Elastic MapReduce probably. Azure has HDInsight. Google has Databrick. And then there's a new contender. I'm calling it a new contender, Databricks, which is actually be able to run on both the Azure and the Amazon cloud. It's like a different take of things. So with that said, let's jump into the first one. If there are any questions, feel free to stop me in between, because we're going to basically jump from distribution to distribution.
Cloudera doesn't have any cloud offering?
Okay, they have something, obviously, but it's you have to maintain it yourself, and it's not, I think it's not a true, let's say, managed cloud offering. It's intentionally left out. Okay. So EMR. So basically what you do in a typical Hadoop cluster is to be high available, to have it always running, you have two head nodes. Because if one fails, you still have the other one, and you can continue work, right? You fix the first one which failed, then you have two again, and you can continue running while one of them fails. So Amazon chose a different setup. So they actually have a single master node. So that's this machine there. And then they made the distinction between core nodes and task nodes. So core nodes are actually more or less traditional Hadoop workers. So they have local storage. And on this local storage, actually there's a HDFS file system, still very similar to a normal traditional Hadoop installation. But then they also have this concept called task nodes. And those task nodes, they don't have any storage themselves. They're only doing compute. So they're only using the CPUs to basically crunch on data, but they don't have locality anymore. So that's the first big change you see from the on-premise. I just mentioned data locality. That was basically one of the key points why we did MapReduce. And now already you see like the first guy, EMR, breaks away from this locality and just says, okay, we're just going to have compute nodes only. I think why this is that for them at least it's more easy, right? They can separate the disk from the compute. So for them, they have big disk solutions like S3. All of the platform providers have that, but also since, let's say, the original MapReduce stuff, a new framework was developed, Spark. I think most of you guys know it. And what Spark does is it just sucks up all the data into memory and starts computing from memory only. So actually not having storage on your compute might not be as bad as it sounds. So it's a shift. So all of these nodes can be spot instances. And I don't know if you guys are familiar with spot instances. So those are basically, you can rent an instance from Amazon, which is called a reserved instance, and you get that. And until you don't want it anymore, it's there for you. But with spot instances, you can make an offer, a bid, for instances which are not used at the moment. So you get a big discount, but then at any time, you can just lose the node without any preemptive warning. So this sounds bad, but if you use them for these task nodes, and you for instance, use Spark, Spark is already designed to be able to handle particular jobs to fail. So if a particular node leaves, it doesn't really matter at all. So spot instances are a really great way for at least Amazon to save you some money by reducing like up to 80% of your task node cost. So, and what you can do as well is you can auto-scale this cluster. So let's say you have one data scientist, he kicks off a job. You just heard from the booking guys that if you have a data scientist who maybe not designed the query in such a nice way, he will just consume the whole network. But then you have another data scientist also wanting to run his job. If you have an auto-scaling policy in place, you can automatically start scaling more and more and more nodes to be able to handle this big request for compute. So it just adjusts to the demand for a cluster. This actually works quite well. So Amazon by default has this yarn available memory, which basically is quite a good metric to base your auto-scaling policy on. And it takes 15 minutes to spin. So if I want a cluster now, I have to wait 15 minutes, and then I have my cluster. So it's not like weeks of calling to Dell guys to give me the hardware now. You can just 15 minutes and you get your cluster. And you actually pay per second. So if I decide to stop my cluster now, it's gone and I stop paying as well. So you can see that there's also this flexibility in if I actually want to keep this cluster running or not, because 15 minutes spinning and billing per second. Yeah.
Is the data on the core nodes, do you actually live physically close to the memory and CPU, or is that all being like virtualized away so it doesn't matter?
No, yeah. So a core node actually uses its local SSD. So with Amazon, some of these instances they have a local SSD. I'm not quite sure how local a local SSD is, but I can imagine that a local SSD is actually in the machine itself.
So it's also Amazon figured out how to make that latency for the task nodes, sucking data out of the core node. Make that disappear.
Okay, let's park that for now. I'm gonna go into that in a bit. Storage. Okay, so what Amazon does is you have HDFS, which is using the storage of the core nodes, but it's not persistent. If I kill my cluster, the data stored on HDFS is gone because it's on the local disk of this core node. So I have to use it in a different way, because if I store my booking.com click traffic, it's going to be gone if I kill my cluster. So what do? You use it for? You use it as scratch, right? So while running the job, you might use it to save some data on it. But when it's finished, you have to move it to a more permanent destination, being S3. So S3 is basically the source and your destination of all your jobs. Because if you put it on HDFS again, it's gone. But S3 actually has this problem, which is called read after write consistency. So if I write something into S3 and I read it like 1 second after, I'm most probably going to get the old version, which is still there. So how Amazon dealt with this is they actually made this thing called S3FS, which is like a combination of S3 together with this Dynamo, which is a key value store, to be able to detect that I'm still reading the old version, trying again until I get the actual version and then returning. It's magical. So third bullet point. So S3 shards your data automatically based on your full path. So in S3 you have this concept of folders, but it's actually fake. So all files are just a full file path only. And S3 shards your data automatically based on the first 4 characters of this path. So if you start your path with a, let's say, I don't know, clickstream data /data, then everything is going to be on a single shard. And you're not going to get the full performance of your S3 bucket because it's a single shard, basically. So if you want to work around this, you have to do something magical. So basically what you do is you add like a random prefix to your data, which allows you to shard, and you then not use it in the table itself. Let's say, for instance, a Hive table. You point it towards this particular folder, and then you have like a R variable, which is basically a random signal used to shard. Or alternatively, It's also a frequently used option. You become friends with one of the Amazon sales guys. You call him every once in a while to shard your data. So there's a button internally somewhere in Amazon. They don't like to push it, but they can actually shard your data for you. Okay, so final thing is it's not that big of a deal. So you can use an external Hive metastore. So Hive it's like your fake database for big data. You can use an external database to be able to throw away your EMR cluster and still have access to all the metadata stored inside the Hive metastore. Everybody does this, so it's not a big pre. So security-wise, no Kerberos. But then again, also Booking doesn't have Kerberos, so who cares? I would consider it a bad thing, but okay. The web interfaces are bound to the master node, and they're listening to the machine itself. So they're not exposed to the internet; they're just local machine only. So if you want to access all of the Hadoop web interfaces, I have to SSH into the machine, and basically you have like a dynamic SOX proxy to access it. It's not a big deal, but you have to work around it. And then basically you give your EMR cluster, you give it a particular role, and this role can access data, which means any user who can log into this particular EMR instance can access that data as well. So if you allow multiple users to access a particular EMR cluster, all those users are going to be able to access the data. And they're going to use the same EMI role. So auditing on S3 level is just going to show this one EMI role accessing data. So auditing is probably going to be a bit tricky. Something else which is tricky. External tooling. So back into the initial introduction I gave. So you have this edge node. On this edge node you have some tooling. This tooling you use to access the data. For instance, a very popular choice for data scientists is Jupyter Hub. If you want to make Jupyter Hub work with EMR, it's doable, but it's tricky. So how we did it is, okay, let me first explain why it's tricky. So you remember this S3FS library or fix Amazon made? So they have it internally on their EMR machine, but they don't let you download it from somewhere. But if you want to use S3, it's really nice to also have access to that particular library. And how to get it is to actually write this post init script from the cluster. So your cluster boots, then you run a particular script. This script makes a tar of all your libraries, including the S3 one. You copy it through S3. Then you spin a VM where you're going to install your tooling, and you download this tar file you just created. You extract it locally, and you have access to the same libraries. So it works. It works fine, as long as the version stayed the same, and there's some corner cases there. But yeah, it's a bit tricky to do. So summary. I would say EMR is a single user cluster, or at least a single user group cluster, because everybody you give access to that cluster can access all the data it has access to. The outscaling is nice. You can use spot instances to reduce cost. But be prepared to deploy / destroy your clusters, because this single head node will fail, and we've seen it failing. Like I said initially, if it fails, your cluster just dies. And it also doesn't recover, so it just stays dead. You have to manually remove it, and it's mumbo jumbo. And maybe this external tooling I just mentioned might be a bit too tricky to be worth the effort. Depending on your use case, maybe you want to save on cost, I don't know. But yeah, it's quite a cumbersome thing. No, I don't think so. So what they do, they package, I think, UI. They package themselves, and you can SSH into the head node and then go into UI. So there you can actually, do something similar. But yeah, UI is not the same as Jupyter Hub, let's say. Okay.
If you really want.
No. But then again, Zeppelin is also maybe not the same again as. So next contender. So HDInsight starts off quite well. So we actually have 2 head nodes instead of 1. So HA is a possibility at least. And then we have 1 worker node at least. But you can have more than 1. So what HDInsight does is it's based on HDP, so Hortonworks data platform. It's like a badly configured variant of it. And it has a lot of different types to choose from. So it has your traditional Hadoop, HBase, Spark, and so for instance HBase and Kafka and R, they just spend some additional components next to it to be able to use. Scaling is possible, similar to EMR, but it's not so auto. So no automatic scaling. You have to use the CLI or this really nice checkbox fill, I don't know, thing in the portal. And somewhat similar to the Amazon case, it takes up to 20 minutes to spin, but you're going to have billing per hour. So you're going to do short jobs. I looked it up today, they didn't. Yeah, they have it for some, but not for HDInsight yet. Probably it's going to be released next week, but still. Probably, yeah.
If you don't pay for it before it's deployed, it actually bills per minute.
Sure? Okay. I stand corrected then. Bills per minute. Yeah, I know that they changed it. Yeah. Okay, then it's billing per hour. It's a bit less tricky, but like it was, let's say, then in Amazon. Let's consider that case. Billing per hour is actually quite tricky. So if you do a lot of jobs, and you deploy clusters with a script automatically, and you pay per hour and it's only short jobs, then maybe you have to combine jobs into a single cluster to be cost efficient. So if you're always paying for an hour and you're only using 8 minutes, yeah, you're still paying for the hour. So Azure took a different approach to the storage problem. So like I said, they don't have local storage on the machines, but they have emulated HDFS with this thing called we call it the WASBock connector, but it's WASB. And basically this WASB connector, it's backed by a blob store or a data lake store. So the difference is a blob store is like your typical S3, but it has a fixed amount of IOPS, so it has a fixed throughput. If you exceed that, then yeah, you're going to be limited. This data lake store, it's like this ultimate scaling thing. So there's a slider in which you can determine the performance. One way to go around that is more expensive. Oh, sorry, that was a missing part. But you can mount multiple of these WASBs to a single cluster. So depending, more or less, this is like the site XML, and you basically define the different, different connections to the different blob storages. Again, similar to EMR, no Kerberos. You get this HTTP proxy, which secures all web interfaces, so you get it for free. Same user as you use to log into, let's say, Ambari, which is included in Hortonworks. But they have this variant, which is called HDInsight Premium, and actually has AD integration. But then you don't get Spark. You only have to use. You can only use blob storage, and it's in preview mode, which probably means that it's broken in some way you can't envision beforehand. Yeah, so basically, yeah, it has Kerberos and the Active Directory integration. Yeah, so that's more or less how you would want to do this. So connecting to external tooling, it's better, but still tricky. So what you can do is, in the Microsoft space, you have this thing called ARN templates. It's basically your typical templating language. And you can specify that it spins an empty node for you. And this empty node is like a VM, which has the connection to the cluster already. And you can run let's say, post-installation bash script on it. So in this post-installation, you install your tooling. So you do your wget, Jupyter Hub, everything else. But also for this tooling, you get the HTTP proxy for free. So even though you might want to link Jupyter Hub to the Active Directory, you still get this login for this HTTP proxy first. You log in there, you click OK, you get the Jupyter Hub login, you log in there again, and so it's not so nice. But you can get around it with some scripting. It's a bit tricky, I wouldn't advise it, but basically you can query which interfaces this cluster has and then bypass the proxy altogether. I did it, I don't think you should. So as a summary, single user, single group, user cluster, no Kerberos again. Watch those IOPS, the blob store is gonna, if you have more than a couple users, it's gonna bite you. And the external tooling is better, but still a bit meh. So. No, it's gonna cap the I/O throughput. So it's gonna, if you have multiple jobs running, you can, at some point you can just scale nodes infinity, but yeah, the performance is not gonna be better because it's gonna be limited by the I/O. Okay, I'm gonna hand over to Tim. It's gonna be tricky, Tim.
Oh God, it's gonna mess up my hair. Oh, awesome. Right, so Databricks. So we've heard Amazon, we've heard Azure. We will hear about Google. Databricks is kind of different, as in it's not necessarily cloud that provides you certain services, but it connects to a cloud to do stuff for you. Mostly, if you're not using Spark, don't use Databricks, because Databricks, per definition, is a sort of a Spark managed service. If you want to use Spark, Databricks is quite nice because it handles booting clusters for you. It provides you with external toolings that you don't have to install. So let's just get started with the basics. I've used Databricks in combination with AWS, so with Amazon. And for that, you kind of can configure a cluster to have one or more master nodes. Usually you set 2 master nodes. You can have 0 or more worker nodes. Why 0? Because you can have long-living clusters and you can basically downscale it to 0 workers when in the night you're not running anything. So it costs less. Everything can be spot instances, and as Niels explained, they can be pretty great because they're quite cheap. You can mix them in any way possible. You can have 4 spot, 6 non-spot, whatever you like. It autoscales, just like EMR does. Therefore, you can have 0 or more worker nodes. The big thing that Databricks provides, though, is collaborative work notebooks. So most of you probably are familiar with something like Jupyter or Zeppelin. So Databricks has its own solution that, for me, it looks a bit like Zeppelin. But it's a notebook that basically can connect to 1 or more clusters. So a notebook is not bound to a cluster. You can write your code there. It can be either Scala, Python, Java, or R. It can be in a single notebook if you like. All of them connect to the same cluster, so on the fly you can do something in Scala, then switch to Python, pull everything to Pandas, do some plotting, then go back to Scala. No problem. This works because everything connects to a single Spark driver. And the funny thing is you can actually work simultaneously in the same notebook. So once you log into a notebook, you can see someone else working on it. You can collaboratively work on a notebook, which is pretty great. You can either choose for interactive clusters. It's a notion that Databricks uses for long-living clusters, which means that you spin it up, you let it run for a few months for data scientists to do their work on, to do some reporting. You can create reports with the notebooks itself. You can basically let it live as long as you want. In the night, it'll downscale to 0 nodes, so it'll be cheap. You can have short-living clusters that use the same billing as Amazon does, except for Databricks as a service. So you have to pay for the service. They have this thing called DBUs, which are Databricks units. So you pay for basically per second billing for these DBUs on top of your usual Amazon costs. The good thing is that they spin ridiculously fast. So if you don't use any spot instances, so on-demand nodes, it can spin in 2 to 3 minutes. I've seen it working, so we've usually used Airflow to schedule some clusters, to basically boot up clusters, do jobs, then shut down the clusters. We've seen it spin up in 4-ish minutes using about 80% spot nodes. So, pretty nice. So this is an example of such a notebook. You can do plotting like you can do in Zeppelin or in Jupyter. Most of the plotting is built in. I mean, you can use the built-in plotting, since everything you run is a Spark job, which means everything that's outputted is some sort of a table, and on a table you can do plotting. You have several options. You can do a time series, a scatter plot, a bar chart, whatever you like. You can even, if you like, you can write SQL here, which is basically your Hive SQL, if you like. It'll still compile down to Spark code and run on Spark. Works pretty great. So, in terms of storage, they have a concept called DBFS, which is the Databricks file storage. It's kind of a layer over S3, if you use it in combination with AWS. And natively, if you have a Databricks subscription, it'll use its own DBFS storage. So if you have sensitive data, they allow you to mount your own S3 bucket and your own AWS account. If you don't specify it, they use their own. So be careful if you configure that. You can read and write from, well, basically anything that Amazon provides, so S3 buckets. So if your Spark job is done, just write to some S3 bucket. Or you can use an external Hive metastore. It's pretty much similar to EMR. So, yeah, do we need tooling? The notebook that they offer is quite nice. You don't need to install another notebook. The notebook itself has version control. Working with Git, however, is a bit cumbersome. So if you want to version control your notebooks with Git, you have to do a bit more work. They provide a thing called the DBFS command line tool, which allows access to everything that is stored on DBFS, if it's not stored in S3. And they have a full REST API that provides cluster management, user group management. You can basically do anything from there. You can spin up clusters, you can shut down clusters, you can view how your jobs are working. So if you want to have some sort of service with, that does something like this, like we did with Airflow. So we started up a cluster from Airflow. We submitted the job to the API, and in the end, we monitored if the jobs were finished by using the job REST API, and afterwards, we basically shut down the cluster using all of this. So you can basically manage everything in a single Python script. So, a user can spin up a cluster that he has only access to, but a user can also spin up a cluster that multiple users have access to. So you can choose to have a multi-user or a single user cluster. As with EMR, if you give multiple users access to your cluster, they all have access to all the data that is living on the cluster. Luckily, you can configure the clusters to say which data they should have access to. You can bootstrap clusters. It is a bit annoying, but you can do it. So let's say you want to run some fancy PySpark job that needs some sort of Python dependencies. You can basically say, hey, on all these nodes, I want to have these dependencies installed from pip or anything else. As I said, the notebooks are pretty damn awesome. There's a free Databricks subscription you can get if you just sign up. I would really advise you to play around with it. Try it if you like to dabble around in these data scientist things. But if you need to update dependencies, for example, if you have written this amazing library and you want to inject it into the cluster, you have to restart it. Whereas with Jupyter, you don't have to. As I said, working with Git is a bit tricky, but it has internal version control. So I think that's about it at Databricks. So as I said, it's a bit different. It's not really a cloud provider. It's a notebook provider, and it manages Spark clusters for you. Then I'm going to hand over to Constantijn. Oh. Yeah, I should give you this thing. There you go.
Yep.
And there is this thing, if you like to walk around.
All right. I'm going to talk about Google's variation. It's called Dataproc. When you spin it up, by default, you get one master node. If for some reason you want 3 because you want a highly available cluster, it can also do that. That's only if you're using long-lived clusters, which I normally don't, but if you want to, you have an option. Why I don't, I'll get to that later. And also spins up workers as many as you want. Usually it wants at least 2. And you can get more if you want. Dataproc is standard Apache Hadoop based. So basically you get, if you just go to the Hadoop site and you download it there, you install that, that's the same thing that Google gives you, which means you can run out of the box, you can run Hadoop, Spark, PySpark, Hive, Pig, and Spark SQL. Everything else, it's still a standard Hadoop installation, so you can add extra tools on it if you want, but this is what it does out of the box. You can scale on the go, so even after you've already started a Spark job and you're like, this is a bit slow, let me throw some extra machines on it, you can, but you still need to actively tell it to spin more machines. By the way, Google also has a service called Dataflow, which runs Apache Beam code, and then you don't need clusters at all. It's just go run my code, and Google will figure out, okay, let me spin up this many machines to do it, and oh, hey, here's more work, do some more machines, and oh, the last bit is easy, so spin down again. But you need to be coding Beam and not Spark for that one. Like the other cloud providers, like AWS has spot instances, but they give you up to an 80% discount depending on the time of day, stand of the moon, whatever. Google just gives you a straight up 80% discount if you want machines that live up to 24 hours. And one of the very nice things is that you have your clusters in about a minute, and they have per second billing. So that allows you to basically spin up your clusters on demand. Like we heard from Booking, one of the problems is like if you have only have a single cluster and you have multiple people trying to run jobs on that cluster, you have scheduling issues. What if your cluster spins up in a minute? That means you can just give every job their own cluster if you want to. Like I also use Airflow for scheduling. Like I hope a lot of you are used to it. But like every job I use on Airflow, if I want to, I can just give all of them their own cluster. Because like if I run 3 clusters in parallel or 1 cluster 3 times as long, it costs me the same thing because it has per second billing. So that's also why I almost never use HA clusters, because I basically use my Hadoop Spark clusters like I use coffee cups from the coffee machine, the paper cups. So just grab one, use it, throw it away, grab another one. Storage, there's a service called Google Storage. It kind of looks like S3. But one of the nice things, it has more IOPS than your credit card can handle. I've seen experiments that went up to 13,000 machines on the thing, and it still wasn't hitting any limits. So I'm not sure who here was planning to throw more than 30,000 machines at their data, but you'll be fine for a while. Also, like with EMR, it has some read before write issues that EMR has, with S3 has read before write issues that you have to kind of be aware of and work around. Google Storage is just immediately consistent. And one of the main things I like about it, it just works. And it doesn't give me any headaches. Again, Google Storage is where you leave your data when you're spinning your clusters up and down. The clusters come and go pretty fast, but you leave your data in Google Storage, and that's persistent.
Is it related to any other Google storage solutions?
You mean Google Drive or? Google Storage is basically, it allows you to, it's basically a blob storage that allows you to just flat files on there. And they have a couple other variations like Bigtable, BigQuery and whatever, but those are more structured. Google Storage is just like, hey, here's a collection of bytes and hold it for me.
And you mentioned it's strongly consistent?
It's immediately consistent. That's... so for the security-wise, Google has two types of credentials. They have Google accounts, which is basically the same thing you use to log into your Gmail, and they have service accounts, which is basically it's a file that contains a certificate, and you can use those to talk to your cluster. So Google has a command line wrapper around things like Spark Submit. So you can use command line tools that are similar to Spark Submit to send your jobs. And that also means that if you have audit logging and stuff, you will see which user started which job. It also has a REST API, which allows you to, with the same type of credentials, if for some reason you want to code and you prefer to use a REST API rather than a command line, it does the same thing. And also Google Databrick spins up VMs for you, and if you have the correct permission, you can get into those VMs. So if you really want to, for some reason, you can get into those VMs, use SSH tunnels, VPNs, or whatever you can do, because it's still a basic Apache Spark cluster that's just running on VMs, so if you can get at it. So if you want to do something exotic, you can, but yeah, it's lots of work yourself, and it's something extra that can break. So if you can avoid it, I would, but it's there if you really need to. External tooling. One of the most common external tools that people want to use is a notebook server. Google Cloud offers those as a service. So you can just say, give me a notebook and the size of machine, and it will spin up a notebook for you, notebook server for you on the specified machine size, which is pre-configured to access the other Google data services. And also it puts your notebooks you work with, it also puts those in Google Storage for you. So if you throw away the notebook service and then later start a new one, it still has your notebooks, which is really nice. If you need some custom software on your cluster, you can you can pass startup scripts. So pip install my thing if you need something from pip. And they also have a couple out-of-the-box examples which spin up often used things like your own. If you want your own Jupyter for some reason, you can. And again, like for external tooling, it's still just a Hadoop cluster, and you can get at it with other VMs in the same Google Cloud instance, VPN or an SSH tunnel, if you want your own external tooling to do whatever you want to do. Again, I'd recommend using the cloud services, if any at all possible, because it's just much easier and yeah, less moving parts, so less likely to break. But if you want to, you still can. So that's this slide. I'd also like to show a small demo. So this is where I want to create a cluster. I can give it a name. I want it in Europe somewhere. The master is fine with a 4-core. I'll give it 1 master because that's fine. I don't need a lot of disk. I'll give 2 standard worker nodes. They also don't need a lot of disks. But I'll make these 8-core machines. And like the preemptible machines, that's the ones that with an 80% discount. I'm gonna want 125 of those. This is the visual UI for humans, but lots of people also want to script this or do Airflow type stuff with it. So they have options here for the equivalent REST call or the equivalent command line. So this is really nice when making Airflow jobs. You can just give the command lines. So now it's spinning up a cluster.
I don't know if everybody saw this, but this is a 125 node cluster. Not your typical on-prem
yeah.
sort of stuff, right?
We're going to have over 1,000 CPUs on there by the time it's up and running. So over here you can just see a list of VMs that are spinning up. This is the master nodes, it's already up. So again, you can SSH into it. You can do it with the normal command line, or they have basically an SSH session in a browser. Again, if your permissions are set correctly that you want to, because you might not want everyone just jumping in your clusters. But there's also a permission set for this. And it's a live demo, so for some reason it's taking longer than usual.
So is this your company credit card or your own credit card?
Company credit card. But like if one thing that really helps is if you can there's like the 125 machines, there's an 80% discount on those, so that really helps. And also if you don't if you immediately throw them away, like I've done this demo multiple times. I used to have a 1 terabyte data set that I live processed but that's a whole talk, so I won't go through that because that takes too long. But in 45 minutes, I can handle can spin up a cluster, handle a couple terabytes, and throw away the cluster, and a few more things. But like now, I have an SSH session into my cluster. So if, again, like I said before, if there's things you want to do over here, you can. You can. Better. Like you can even just run an old-fashioned Spark shell in here. Like again, I'm not sure why you would want to, but you can get at your cluster, and if you want to do weird edge cases, you can.
You mentioned this is SSH, but this is a browser window.
This is SSH in the browser window, but you can also do a real SSH session. But they support both.
Did you just SSH it to the head node?
Yep.
In this case, the head node is also used as an edge node.
I can SSH into whichever node I want, because it's.
I'm referring to the slide of the
Yeah, okay. So
where you have separate head node and separate edge node. So the edge node is usually running a Spark line, like this case.
Mm-hmm.
Now you're running the Spark line on the actual head node. So
Yep.
Okay, so this boils down back to the traditional thinking. Back in the days, we had on-prem.
By the way, it's up now. We have 1,000 CPU cluster up and running.
But back in the day, we did on-prem. You had the head nodes, and the head nodes needed to have big memory because they had the full index of HDFS in memory, right? And if you started to load those machines, then probably your this index or your name node would fall over and mayhem. But now, because all these file systems are fake anyways, there's no such thing as a name node anymore. Probably still one there, but it doesn't need more memory because there's no HDFS. So why would you need the full index in memory? So the head node in all of these cloud-based Hadoop distributions, you typically don't need big memory there. And you can even use them for this sort of stuff.
By the way, the cluster was up and running in just about a minute, but because we were talking, it took a little bit longer. I'm also now going to throw it away again because this, again, 1,000 CPUs does burn through money in quite a hurry.
I was thinking about the company, yeah?
Oh, by the way, like everyone that uses this at some point, usually after it goes wrong, ends up writing some kind of Reaper script, like list all the clusters I have running. If it hasn't done anything useful for half an hour, and it's not a data scientist cluster, or it's outside of office hour, kill this thing. That's gonna pay itself back definitely sooner or later, probably sooner. But now it's throwing it away again, and in a little bit it will be gone again. So this was spinning up 1,000 CPU, 1,016 actually CPU cluster, and now it's going down again.
That's it,
Yep. Talk, and I did it 3 times just to make sure to prepare it, where I handled a couple terabytes of data, and that was about 10 euros for the whole thing every time I wanted to process a terabyte of data.
Can you, I don't want to reach in your pocket. Thank you. So concluding. So all of them, they provide like an on-demand cluster, right? We've seen that in the extreme case even, where Constantijn just spinned this Google cluster. So EMR and HDInsight are somewhat slower, still minutes, like 15, 20 minutes instead of the 1 or 2 minutes for the first two. So maybe you want to, if you really want to go full-blown spin clusters on demand, really go for it. Dataproc and Databricks might be the better solution for you because of this much lower latency. Then if you want to have like a managed on-site cluster in the cloud, I think HDInsight Premium will probably be the best solution. It has HA, like HDInsight, but it also has the Active Directory integration, so you get much better security. You get some better auditing at least than just the security you get for your typical cloud platform. A bit more than everybody who can access all the data. So yeah, more or less the next point. So you will have security at the cluster level. So everybody who can log in can probably access all the data that the cluster can access. So this might or might not work for you, and you have to. I see the cameras videoing Constantijn. Still working. But this on-demand way of working is a radical shift. You need to think differently and act and be integrate with these clusters differently than we did in the traditional on-site way, right? You just spin new clusters for every job, like Constantijn was just mentioning. You have an Airflow job, it gets its own cluster. Why would you care about queues and fair scheduling and everything else if you just spin a new cluster and just, why deal with all that hassle? But having more than one cluster, or probably bigger corporations have more than one cluster, but having really many clusters, how are you going to deal with the management of that? if you're going to have one for each user and you have a couple thousand data scientists working for you, how are you going to do all this auditing and this? How are you going to make sense of all this mayhem? So think about that. And also, I think the Databricks solution is really nice. It integrates really well with this new on-demand way of working with Hadoop clusters, but the open source tooling is not ready yet. You can connect Jupyter to Spark context, but what I would like to do is run this particular cell on a cluster, and if it's done, just throw away the cluster again. And at a much finer level than just calling get Spark context at the top of my notebook and booting something. I want to have more fine-grained control over this booting and shutting down of clusters, and that's not there yet. Also, what you saw with the tricky part of the integrations, how are we going to manage all these config files, copy these libraries through S3 onto a Jupyter machine? It's not really there yet, I think. So that really makes a good case for the Databricks solution. Oh, that's actually it. I forgot the hiring slide. I'm going to do it manually. Oh, just yeah, okay. So like booking, yeah, we're GoDataDriven. We're a group of fun engineers and data scientists, 30 in total, and we're always hiring. So if you want to burn some money of our company credit cards and spend some clusters in your free time, you're more than willing to apply. And thank you for your attention. So, any questions, Robert?
So, it seems like the Databricks solution spins up faster, seconds to minutes, it's easier to have tooling, and you get low folks points out of the box. Is there a situation where you don't want to launch a cluster, but you'd rather go for Amazon than Databricks?
I think maybe the Hippo more or less solves it. So, I think from a technical point of view, probably Google is the best out of the bunch. I like the integration with Databricks. So if you're really into the, let's say, data science workflow, then Databricks may be even better than Google at this moment. But yeah, sometimes there's different people in the organization deciding the cloud provider. and you're bound to a particular cloud. I know Microsoft has Active Directory. That's always a big plus to convince people to run on Azure. But then again, so now...
Google integrates with Azure with Active Directory just fine.
Okay, but you don't have to convince me. But then again, there's rapid development in this space. Now Google is maybe a bit better. Amazon maybe will do something in the next month, and everything will change again. So yeah, yeah, it doesn't. In the end, I'm not sure if it matters that much. Any more questions? No more questions. Oh, one.
So you can rapidly spin up a cluster, and that's great, but your data still needs to be there, right?
Yeah.
That's why you use S3 Google Storage or Azure Data Lake, because those stick around.
Right.
But you only pay per gigabyte per month.
Which is great, unless you have petabytes to take.
Okay, so yeah, but I think that okay. You said what about petabytes of data? You're going to pay a lot. I think that's true for all cloud services, right? Once you cross a critical threshold yet again, then maybe on-prem makes sense again. Why? I think for the somewhat larger corporations in the Netherlands, it's hard for them to find the people to manage these Hadoop clusters, but yeah, for the booking case, probably you have a couple guys who are more than qualified to manage Hadoop clusters.
Well, so I asked because the question was earlier, like why does booking not move to the cloud? And so I would ask you the same question. Do you think we should? And if so, which one?
Okay, so I think it would solve some of your problems. Like the things with the scheduling, that's clearly solved here. But yeah, the data, it's going to bite you. Yeah, that's for sure.
If you for your ad hoc data sets, you get get it down to $10 per terabyte per month. So that's still 10K per petabyte per month, which is not cheap. But then again, doing a couple petabyte on-prem is also not cheap. But something like in the Google solution, another service is called BigQuery, and putting all your data for ad hoc queries in there. And that's basically a cluster that's already up and running with a couple tens of thousands of nodes below it. And you can just fire queries at it. And
so can this thing also occur BigQuery? Can I use the data that's in there? Can I use that as a source for?
What I usually end up doing is my raw data in Google Storage, because that's just bytes, a collection of bytes, and I run that through Spark in Databrick, and I put that in BigQuery. And also, if you want to be a bit more advanced, you can set up a streaming job. Where it just you put things on a queue, and it ends up in BigQuery.
Okay, so BigQuery, there's a big use case for BigQuery. I'm not sure if this is the one, because you're going to pay per query.
$5 per terabyte process.
Yeah, so but if you're doing ad hoc analytics and you want to have like a really scalable, fast, maybe not so fast, but quite fast over big volumes of data, then probably BigQuery is the way to go. If you're looking for file storage, then BigQuery is not the way to go. Okay, I want to thank you all for coming. We can have some more drinks at the bar, and then I think in like half an hour I'll kick you all out. Thank you.